Now we are going to look at the relations and functions. But before that, let's start with the relations. Now, since we started with the set theorem, we talk about a lot of relationships between two or more sets. Some of them are intersections. We talk about the subsets, equality of the sets, Cartesian product, and so on and so forth. So these are some kind of relations that we have so far as the set is concerned. Now, if I talk about a relation, what's a relation? It gets a link or a tie between two or more sets. How one set is related to other one, or how members of one set is being related to the other set. That's what we call the relation. Now we can have maybe the relation of a student of GCTU whole campus, level 100, and that of the Accra students. Is there any link between you? Yes. Why so? Because you all study the same course, provided you are under the same program. Okay, so there's a link between you and those in Accra or anywhere so far the GTU campus is concerned. So relation is just about the link between two or more sets. It is about how two or more sets relate to each other, as I've already said. In mathematics, we can talk about relation as, let's say, less than, can the word or the phrase less than is greater than, is perpendicular power to represent a relation. So these are all linked. Now, when we come home, we can even talk about the relation between the maybe the men and the women, the couples. We can talk about the wife and the husband, and the link between them. We can also talk about the denomination of people. Are you okay? And then maybe the culture of the people within a particular area. So we can talk about all this as a link between two or more sets. Any question here? Is there any question, please?
No, please.
Now, is the network okay?
Yes, sir, it's okay.
It's okay.
I'll change it. So we hope
Okay.
that will be okay.
Powerful, sir. Thank you.
Yeah. So now let's talk about binary relation, the binary. Now, binary in mathematics means the two. It means we are not going to talk about two meshes. So let A and B be any two sets. Then a binary relation or simply relation from A to B is a subset of A cross B. Now, before I continue, what's the meaning of A cross B? We did this one that set here. What's the A cross B? Yes, huh?
So I think A cross B is the coordinates of A multiplying the coordinates of B.
Are they multiplying?
Crossing the coordinates of B.
What do you mean of crossing? What do you mean of that crossing?
Okay.
Are
So,
you
I
live or what?
okay, so I think the coordinates of A being paired with the coordinates of B.
Yeah, we are pairing the elements of A and B, whereby A element becomes the first coordinate, followed by B element. Are you okay?
Yes, sir.
I will call it like Cartesian product. Do you remember it?
Yes, sir.
So we are now going back to set theorem. So in the binary relation or simple relation from A to B is a subset of A cross B. It means if you're having a set A and a set B and you want to find a relation between them, then there will be the subset because you're now going to pair A and B, and all of them may come from the Cartesian product of A and B. That's what we are saying, that is a subset of A cross B. as we move on, if you have a question, you can ask. Now let's suppose R is a relation from A to B. Suppose R is a relation from A to B. Then we have R as a subset of a Cartesian product, as I have already said, A cross B. That's a set of ordered pairs where for each pair, the first coordinate belongs to the set A and the second coordinate also belongs to the set B. I've already explained this one to you. Now, these are just introduction. Let's move on to the definition of binary relation. Binary relation. A relation between two objects is a binary relation, and it is given by a set of ordered couples. A set of ordered couples. Now, if S and Y are two sets, then a binary relation from set A to B is denoted by AX, or from set X to Y is denoted by XRY. These are now the relations. So to the relations are from the set X to the set Y. That's how you write it. And you can see that X is related to Y. We can also see that it's a subset of X cross Y. It's a subset of X cross Y. And that into black, we have the Cartesian product. Now let X and Y be non-empty sets. Then any subset of the Cartesian product X cross Y is called a relation from X to Y. I've already explained everything to you, get more emphasis. So if you're having a binary relation from, let's say, a Cartesian product, if X is one of the sets and Y is another set, now we begin from X, we are now linking the elements of, or we are mapping all the elements of X to Y. Or at times not even, or some may be even mapped, some may not be even also mapped. So we are now taking the elements of X to Y. I think how you write it, you say that X is related to Y. So we have X R Y. So let R be a binary relation. Then a domain set. A domain set or domain of a relation R denoted by DR. So if I find the domain of this relation, we can now represent that one by DR. Then D into bracket R. D stands for the domain, and the R now stands for the relation. Now the domain contains all the first components of the ordered couples. All the first components of the ordered couples. So if we have the ordered couples, then the domain will be take out all the first coordinates, all of them, and put them in the set. That will be the domain. So domain contains all the first components of the ordered couples. That is D of R or DR now. In the set of X, it said that X, Y belongs to R. So X is said that X, Y belongs to R. So we are taking all the relation of R, now pick all the X coordinates, the first coordinates. That's what will be the domain. That's the meaning. Now, if R is also R equal to X cross Y, then the domain is subset of X. The domain now will be subset of X. So we get the domain for the set of X. The domain belongs to what? The set of X. All the elements, some of the elements of X will be part of the domain. Now, similarly, the range. Now you have the couples, the ordered couples. We have the first coordinate, we have the second coordinate. So the first one will be the domain, and the last one will also be the range. So the range of a relation denoted by R of R it also contains the second component of the ordered couples. Therefore, the range is given by the set of Y. It said that X, Y belong to R. It means we go by the ordered pair of the relation, pick out the Y component, that's the second component, and put that in the set. That will give the range. Now, the range is also called the image of the domain. The range is the image of the domain. We shall come to that. So therefore, we can also say that the range is a subset of Y. Range is a subset of Y. So what are you saying? You are saying that domain is for X, the range is for Y. Peter, are you getting it? Are you there?
Yes, sir.
So can you go over again?
Where? Where, please, where?
From the further to X.
Here. This way, please.
No, sir, the second one.
The
The
domain
second
of
one,
right.
relation.
But it's related to this one.
Yes, sir.
What we are saying that now if you have the relation like R with the X plus Y, that means we are not pairing the elements of X and Y to get the ordered couples. Okay. So for the pairing, we are the first
Yes,
one
sir.
be the X coordinate. We are second one be the Y coordinate. So domain is you pick out all the first coordinates of ordered couples. And that will give you the domain of the given set. And that domain comes from what? The element of X. So we are saying the domain of R is a subset of X. It means any element of the domain comes from the set of X. It's okay there?
Yes, sir, I got it.
Now when we came here to, as you asked me to go over it, we are having a range. The range is also defined as Y. It said that the ordered couple X, Y belong to R. It means now you go to the ordered couple, now pick out the Y entries or members. It means the second what? Component of each ordered couple. It means range is for Y as domain is for X. So you pick out the element of range from Y, the set of Y, and then pick out the element of domain from the set of X. That's what I'm talking about. We are having some examples. When you go there, maybe you may understand it well. Are you again? Are you again? The one who has a question, are you okay?
Yes, sir, I'm okay.
So now let's go to the example and see, maybe that will throw more light on it for you. The boundary relation can be represented on a diagram as shown below. Now you're having let X be the set of 1, 2, 3, 4, and Y be the set of 5, 7, 9, 11, 13. These are two sets, X and Y. And we are going to have the relation R. Now that is now giving us the ordered couple, the set of ordered couples. We refer to as 1, 5, 1, 9, 2, 13, 4, 7 as the relation. So to me, if I want to get the domain here, what should I do? Go back to each couple or each ordered couple, pick out all the first element out. That will give you the domain. So to me, when you go here, you have 1 here. So this was the element of the domain. Now the same one is here. So pick only 1. Now you have 2 here as another element of domain. We have 4 here as also element of domain. Therefore, the set of domain for the relation now become 1, 2, and 4. That will give our due about R with the set of 1, 2, and 4, the first component for each ordered couple. Now the range will be the last one or the second component. So the range will also be 5 here, 9, 13, and 7. Therefore, the set of range, this one now will also be the set of 5, 9, 13, and 11, and 7. Are you okay? So upon all my explanation over here, this one can even throw more light on them for you to understand what is the domain, what is the range, when it comes to relation. Is it okay?
Yes, sir.
Yes, sir.
So let's represent the relation on a diagram and hence fix the domain and the range of the relation. I've already done the range and domain. So let's go to a diagram and see. So this is a diagram now. So we see that now we are now having what? X, R, Y. It means X is related to Y. Therefore, we are taking all the elements under X in the domain, and the element under Y will also be the range. But here, not every element under one is part of the domain of the range. We shall come to that. But all what you have to know that the range comes from the set of Y, and the domain also comes from the set of X. So we have X is related to Y. So Y maps to 5, 1 maps to 9. So 1 now has 2 partners from the Y. And this Y we call the codomain. Codomain. So we have 1 mapped to 5, 1, the same 1 mapped to 9. Now we have 2 mapped to 13, 4 mapped to 7. So it's not having any partner from the domain. Now for the set of X, so it's not having any partner for the set of X. Now from the set of Y, 11 is not also having any partner. Are you okay? So therefore, if we are asked to come out of the domain, now we are talking about those who have the partners from X. That will form the domain. And in the domain now will be 1, 2, and 4 as our domain. Now let's check this one with the ordered couple. So we are picking all the first.
Alex, sir.
The question, please.
Yes. Why is the domain 1, 2, and 4?
Yeah, so that's why we come back here to the ordered couple. Are you okay? Now you are the domain is when you go to the relation R, domain now is the first component of each ordered couple. The set of all the first components. So when we come here, we have 1 here at the first, 1 first, 2, and 4. But in this one, the same as we pick only 1. So therefore, the domain now become 1, 2, and 4. And don't forget that I've said that the domain comes from the set of X. So these are the set of X, which is 1, 2, 3, 4. So when we go to the ordered couple here for the range, we don't have a 3 inside at our first component. Therefore, 3 is not part of the domain. Are you okay?
Okay, but sir, how do you create the couple, the ordered couple?
No, you are beginning this one to attend. You give you a relation. Okay, but this one it has been given to you.
Okay.
This one has been given to you.
All right.
But if you want to do it, then we just give the clue. Are you okay? To do that.
Okay.
So you see that 3 is part of X, but it's not part of the domain. It means 3 will not get any partner. Now 11 is also part of the Y, but not part of the range. Because when you go to the last component for each ordered couple, we don't have 11 there. Therefore, the domain now will be 1, 2, 4, and the range now will be what? 5, 7, 9, 13. Am I okay here?
Hello, sir.
Yes.
From the previous example,
And let's go back.
is the codomain the same as the how do you call it? What you just
range.
mentioned, the last one, is it the same as the codomain?
Codomain, yeah, codomain.
The range, yeah, the range. Is it the same as the codomain?
If I come to the at time the codomain the same as the range. At time, no.
I mean, is the range the same as the codomain? From your explanation.
From my explanation, you see that you see at times, codomain is the same as the range, and at time, no. And this example that you have set here is now even differentiating codomain from the range. Are you again? Now when you go here, codomain now will be the set of Y. All the elements of Y are members of codomain. But
What about
the
the
range
range?
will be those who are having partners.
Oh, okay.
I hope you are getting it now.
Yes, sir.
So you see that those who are having partners are 5, 7, 9, and 13. That one will form the range. So range is subset of codomain. Range is subset of codomain. And why is what we call the codomain? Why the codomain? Are you again?
Yes, sir.
More questions, please. If you have a question, ask before we move on.
So please,
Sir.
X is always the domain and Y is always a codomain.
Don't forget that X is not always the code, the domain. But domain comes from the X.
Okay, I
And the range
understand.
also comes from what? The codomain or Y.
It's
Now look at
clear
something
now,
here.
sir.
When we are talking about the code, the domain, here we have X is what? The set of 1, 2, 3, 4. But when you come to the other pair, we don't have 3 here. Do you have a 3 as the first component? No. Are you again? Therefore, we cannot say that X is a domain. No. The domain now will be those components which are now the first part or first component of each other couple. So the domain now becomes a set of 1, 3, and 4, but not 3 here. 1, 2, and 4, but not 3. 3 is not having a partner. So 3 is not part of the domain. Are you getting it? So X is not the domain. No. The domain is those from X which are having partners from the codomain. In the same manner, the range is also those of Y, which are also having partners from the domain. Any more questions?
So, sir,
Yes,
hello.
yes, talk.
All the components of Y are codomain.
All the components about
Of Y
Mhm.
are codomain.
Yes, Y components are code. The set of Y is the codomain. When it comes to relation, the set of Y is the codomain. But the set of X is not domain. Agree?
If it's my line got broken there, did you agree that Y components are all codomain?
Yes.
Okay, thank you.
So it means from the codomain that you get the range. And the range are the members of the codomain which are having partners from the domain from X. Are you again?
All right. And so you said that paired couples are always given.
Not always. If you are not giving the couple, the relation, the other couple, then you give the clue or the mapping or the formula for you to get
Okay.
the other couples. Are you getting it?
Yes, sir.
Let's go small. You understand it. You understand. You are just started. So if I can move on, then we're having the domain now, as we already understood it now, will be those who are having a partner from the Y. So we have 1, it's having a partner, 2 is having a partner, 4 is having a partner. Therefore, the domain now becomes a set of 1, 2, and 4. Now, range is also those from Y who are also having partners from the X. So we have 5 is having a partner, 7, 9, and 13. So that also forms the set of range. So you can see that domain comes from X, while the range also comes from Y. That's why I said domain is subset of X. Domain is subset of X. And we also see that the range is also subset of Y. The range is also subset of Y. So for any relation X related to Y, domain belongs to the set of X, and then the range also belongs to the set of Y, as already explained to you. I think it's okay. We can move on to the example.
Yes.
Or any other question? Okay, let's move on. Let's consider the following six. A, the set of 1, 2, 3, 4, 5. And B, the set of A, B, C, D, E. And the relation R at the set of, now you have the other couple 1A, 1C, 2D, 3E, and 5A. Find I, the domain of the relation. II, the range of the relation. B, represent the relation on the diagram. So before we go to the solution, can we just identify our set of domains?
Yes, sir.
A question, please.
Yes, sir.
Do you have a question?
No, sir. I said yes, we can identify it.
Yeah, so let's see if we can identify the set of domain here. What's the domain?
1, 2, 3, 5.
1, the set of 1, 2, 3, 5. Good. How about the range?
A, C, D, E.
A, C, D.
The set of
C,
A,
D,
C,
E.
D, E.
Yeah, A, C, D, E. The set of A, C, D. That's the range. You are doing well. Today seems to be better for you. Eh? Now let's go and represent it on the diagram. Yeah, so that's the domain, that's the range. And this is the diagram now. So you can see that the set of A, now 4 is not having any partner, or 4 is not mapped to any element. Therefore, 4 is not part of the domain, even though it's part of set A.
Yes, sir.
Now, in the same manner, B from the B here, the set of B here, is not also having a partner from A. Therefore, B is a part of codomain, but not the range. That's why the set of range don't have the B also inside here. So now you cannot differentiate from the range, codomain, and the domain. Can do that differentiation. Are you again?
Yes, sir.
Good. Now, number 2. Let the relation R be or the set
Yes,
of
sir.
yes.
So as many as the times the domain, the set of A, as many as the times 1 matches to, or I mean the number of couples 1 is included, you draw the those number of lines, right?
Yeah, you see, if you look at the
let me
other
say
pair,
this
like,
way.
let's go back to the other pair here. That's what I mean. One is mapping towards A. So you can say that one is the image,
Yes, sir.
or A the image of one. Are you again? It's in one map to A.
Yes, sir.
Now the same one also map to C. So it means see the image of one. Are you again? So it means one is
Okay, I
having
get
two images,
yes,
A and C. So with
So
the
in the
other
diagram,
couple,
you draw it to as
what?
so in the diagram you match the one to
Yeah,
the
yeah. You
number
need the
of
other couple to do the mapping.
okay, sir.
Are you again? So 2 is map
Thank
to
you.
D, 3 map to E, and 5 also map to A. That you can see A, 1 map to A, 1 map to C. Now 2 map to D, 3 map to E, and 5 map to A. So with the other couple to do the mapping. Agree?
Yes, sir.
Good. So let's do example 3.
Yes.
If no other question. The
Okay,
relation
sir.
R now is given by the other couple X1, Y1, X1, Y2, X2, Y1, X3, Y2. State the domain and the range. Then represent the relation on a diagram. So let's say the domain, or the domain.
X1.
So that's X1, X2, X3.
Don't forget it's a set.
The set of X1, X2, X3.
The set of X1, S2, S3. Good. What about the range?
A set of Y1, Y2.
Y1, Y2. Good. Y1, Y2. Now I can now represent them on the Venn diagram at this. Oh, but you're doing well. They seem to be good. You're doing well. So that's the diagram now. Are you seeing that? Now X1
Yes,
is
sir.
having the two images, Y1 and Y2. S2 is mapped to Y1, so it means the image of S3 is Y1. And the image of S3 is also what? Y2. So that's the diagram now. Very simple. Let's go to this example. Now let A equal to the set of 3, 6, 9. And B equal to the set of 4, 8, 12. Then I, that the relation, equal to the set of the other couple 3, 4, 3, 8, 9, 12. It's a relation from A to B. Two of us. Two of us.
So it's true
Why true?
because the set R, we could see that the couple is 3. So we pick the first component of A and pair it to the first component of B. So we see 3, 4, 6.
So to make all the first components are from A and all the second components are from B. Are you okay? That
Yes,
makes
sir.
it was true. Okay. What about the I? 3, 12, 6, 4, 9, 8. Is it also relation from A to B?
Yes, sir.
What about II?
No, sir.
But it's what?
Okay, B to A.
It's
Yes,
what?
sir.
Relation from where?
It is. From B to A.
From B to A, because all the first components are from B and the second are
Yes,
from what?
please.
A. So from B to A. Now let me ask you a question. What is the range of III?
It's
What is the range
369.
of II?
369.
369.
Yes, sir.
But is it from the set of A or B?
It's from the set of A.
Set of A. So now the range now is now for the A instead of what? The domain B from A, as we always do. Are you again? So we obtain it. We obtain it. So the range of A now, normally the range should be what? From the B. And then the domain now go from A. But according to the third I, it means that we are not taking the A and B. Therefore, B now has become the domain set that we can get the domain, and A also becomes the set that we can get the range. So take note of the order. Okay, so from the above set A and B, let's show that the relation R equal the set of other couple 2, 3, 3, 8, 6, 8, 9, 4. It's not a relation using the diagram. So why are you saying that this is not a relation? Why? Before you go to the diagram, why are you saying that this is not a relation?
Sir, 2 is
Hello,
not
sir.
part of the set A.
Come again, is that what?
2 is not part of the set A.
2 is not a part of the set A. Okay, so 2 does not belong to
Yes.
an element of A.
Yes.
Okay, 2 is not an element of A. Good. So therefore, that was disqualified. Apart from 2, which one again?
Three. Three is not an element of B.
3 is also not from B. So therefore, this other couple disqualify the relation, this the relation. Are you again? Therefore, you have the diagram like this. 3 map to 8, 6 map to 8, 9 map to 4. So I just from the diagram, 2 does not belong to A, 3 does not belong to B. So the pair 2, 3 is not found on the diagram. Hence, R is not a relation. With respect to the Cartesian product A cross B. Now let's see example 2. Let X be the set of 1, 2, 3, and T 2, 4, 7. Then we are given the relation as 2, 1, 2, 4, 2, 7. Now it's 1, 2, 2, 4, 2, 7. With the help of the diagram, show that R is a relation with respect to S cross T. Ready to? It's R the relation. So we cannot draw a diagram. We have X here, which is 1, 2, 3 here. We have T is also 4, 2, 4, 7. Then we go to the relation and we make the mapping. So 1 map to 2, 2 map to 4, 2 map to 7. So since all the other pairs of R can be found or traced from the diagram, then R is a relation. That's all. Now the third example. Let A equal to the set of 1, 2, 3, and B equal to the set of AB. Then A cross B is given by 1A, 1B, 2A, 2B, 3A, 3B. If R is equal to the set of 1A, 3B, then R is the subset of A cross B. And R is the relation from A to B. I think it's true, eh? Is it true?
Yes, sir.
Good. Now, if for each pair AB, where A belongs to A, that is big A, and small b also belongs to big B, then exactly one of the following is true about the relation. One of them is true. We have the set or the pair A, B, where the first component comes from A and the second component also comes from the set of B. Then when it happens that way, then one of these is true. One, A, B belongs to R, that is relation. Then you can say that A is related to B. And A is related to B, we have already been indicated over there. You can say A, R, B. Now, we can also have a point whereby A and B, though they are also part of this other pair, but it's not part of the relation like this. A could be like this. Like this, yeah, A1 and then maybe 3B. So when it happens that way, we have A, B does not belong to the relation. It means that A is not related to B. And this is how we write it. A, and then we call the R. It means not related to B. So we say A is not related to B. It means we can't find this or that couple here inside the relation set, which is this. What happened that way? So what we are saying is that even though the pair may be given or may be found the set given, but it may not also from the relation given. When happened that way, then they are not related. Example 4. Given A equal to 1, 2, 3, and B equal to X, Y, Z. Now the relation is given as 1y, 1z, 3y, 3x. Determine if R is a relation from A to B. B, with respect to above relation R, identify which of the following are related. So let's determine if R, this one, is a relation from A to B. Let's determine that before we move on to B. Is there a relation from A to B?
Yes, sir.
Why?
That's because all the sets of A, the set of A that can be paired or mapped to the set of B.
Oh. Actually, all the set of A are mapped
Not
to the
all.
set of B.
That's not 1 and 3. It's 1 and 3 that are mapping to Y, Z, and X. 1, X, and Z.
So the relation from A to B, that's what we mean it. That's a question now.
No, sir.
No, sir, why? Why no?
From the top example, he said AB belongs to R, then we can say A is related to B. But here, the two is not part of the R. So I'm not sure it's related to A is related to B. The 2 is not part of the R.
So from all what we have done, this one is qualified. But
Yeah, I think it's related.
Hello, sir.
Okay,
It's relating. It's relating.
Why? Why?
But the ordered pair of the range can be found in the other ones to the when they trace it.
But not is about we are talking about, is it a relation from A to B? Not any relation.
Yes, it's a relation.
It's a relation when A, B belongs to the range.
Yeah, but the question now is, is this the R? Are you there? Is it a relation from A to B?
No, sir, because the 2 is not part of the range.
Yeah. So
Yes,
it's a
what question?
relation.
I'm confused.
That R is relating to A to B.
Why?
A set of A, which is 1, 2, and 3. When the range is 1 to Y, 1 to Z, 3 to Y, and then 3 to X. And a set of B, we have the X, Y, and Z there. So when we map A 1 as from the set of A, we can map 1 to Y there. 1 to Z is there. 3 to Y is also there, and 3 to X is also there. So since we can map up the pair of this set of A is related to this one, then that means the relation to A and B, or if I'm lost too, I'm yet to be corrected.
Yeah, please clarify for us.
Yes, Now you see that if you have a relation where we have A being the first set, I agree, and the B being the second set, if you want to see if a relation from A to B, it means all the first components or the other couple should come from the set of A. All the first components of the other couple should come from A. And all the second components should also come from B. That made it a relation from A from B, A to B. Are you okay?
Yes, sir.
Because it is a relation all right. Are you okay? But it is from A to B. So if we are measuring the A first, we are moving from A to B. When we go to the other couple, then we are expecting every first component should come from A. And every last component should also come from B. That's the other couple. That made it A from A to B. So are you getting it now?
So it's not a relation from A to B, right?
It's a
It's a
relation from A to
relation.
B.
It is.
It's a relation.
Okay.
This one is from A, the set of A. This
Yes,
also
sir.
from the set of A. This one from the set of A. This is the set of A. So all the first
Okay.
components are from the set of A. So it means we are starting from A, we are ending at B.
Yes, please.
And all the last components, the second component, are also from the set of B. Are you getting it?
Yes, sir.
So that makes the relation from A to B. So A means A is the first component and B the second component from all the other couples in the relation set. That shall not be confused. Are you okay? We did it over and over and over there.
All right,
Yeah,
sir.
okay.
So when you are asked to determine if R is a relation of A to B, that is the explanation to give.
Yes. Check the first component, the second component to see if they follow that order of the mapping or the relation.
Okay.
I'm sure it's okay now.
Sir, yes, sir. It's okay.
Good. So somebody was confused here. They saying now, assuming that we have maybe we are bank, let's say 3 and let's say 3 and what, or we having 3, we having also even Z here. So our blend will be X3 here. I write that X first. Now bring the 3 here. Are you okay? So even though we have X as a member of B, we have 3 as a member of A, all right, but we can't find them in R here. That now bring it back here. Are you okay? So to me, this set X3 is not part of the equation. So what happens that we cannot say that we have A is not related to B. But for this one, all the first components are from A, and all the second components are from B. Therefore, the relation from A to that of B. Good. Now let's go to B. With respect to above relation, R, identify which of the following are related. Now, 1 is related to Y, 2 of us.
So it's true.
It's true, why? Because we have 1 Y.
That's from the first. Yeah.
Yes. So it's there. Why 1 Z?
It's also there, sir.
Okay, what 3
True.
Y?
Yes, sir.
No, sir.
3 Y?
3Y is there. Is there.
It's there. This one, good.
Is there?
Why 1 X?
It's also
It's not there.
So this is not what they are not related.
1
One is
X.
related to X. Are you okay?
It's not there.
Good. 2R.
2R is not there.
Not there. Now
It's not
2Y.
there.
It's also not
It's
there.
not there.
2Z.
Not there.
It's not there.
3X.
Yeah,
Is there.
3Z.
It's not there.
Not there. So to those who are rated are 1Y,
It's not
1Z,
there.
3Y, and 3X. But the rest are not related. It's okay now. Have you understood it? Have you understood it?
Yes, sir.
If you have a question, ask you. I've taken my time this evening for you. So these are the explanation to that. Now, example 5. Let X equal the set of 1, 2. Then X squared is equal to X cross X, X cross X. And here X cross X now is given about that the Cartesian product 1, 1, 1, 2, 2, 1, 2, 2. You know this already. Now let R on X be given by the description X related to Y or SRY. Implies you have X plus 1 is odd. Let me go over that question again. Let X equal to the set of 1, 2. Then X power 2 is equal to S cross S equal to the set of the ordered couples 1, 1, 1, 2, 2, 1, 2, 2. Let R on X, the relation on X, be given by the description X R Y. That will go to what? X plus Y is odd. Then 1, 2 belong to R and 2, 1 belong to R. The other pair 1, 1 does not belong to R, and the 2, 2 does also not belong to R, since their summation do not give odd numbers. Now what are you saying? Now you are beginning the set of X. And you have given the relation of the ordered couple with the S squared is what? S plus X. All this. Now we want to find the relation on X. And that relation is described by or given by X R Y. It means we are now relating X to Y. Now, if you go here, we have X being the set of, let's say, 1, 2. We have Y being the set of 1, 2. That's why we are crossing X by itself. So we have X is related to Y. That will give you us X plus Y is odd. So what we are saying here is that when you go to ordered couple, we know the first one is X, the second one is taken to be Y. Then you have SY. But we want to get a relation whereby when we add the two components in each couple on each pair, the answer should be odd number. So this is why we have given the clue for the relation. So we have X related to Y now is given by X plus Y is odd. So to me, go into the ordered couple, add the two components. The one that will give you the odd number becomes the part of the relation. Are you getting it?
Yes, sir.
Good. So to me, don't take the first one. 1 plus 1 is what?
Yes, sir.
What 1 plus 1?
2.
2.
Is it odd?
2, sir.
No.
But if this is out of the relation that we are talking about, so it's out of the set of R. Now 1 plus 3 is what?
It's 3.
So is it odd?
That's odd, sir.
So to me, now this one has become the part of the ordered couple for R.
Yeah.
2 plus 1
Also 3.
is
and it's
also
odd.
odd, eh? What about 2 plus 2?
4. That's even.
That's even. So it means that the relation that we are not talking about now, R now will be the set of 1, 2, 2, 1. So this here, we are giving the mapping for you to come out with the relation. So we are saying R now will be giving us what? X plus Y is odd from this cross product here. So we are saying that then 1, 2 belong to the relation R, and 2, 1 is also belong to the R. The other pairs 1, 1 does not belong to R, and 2, 2 does. So since their summation do not give odd numbers. I think it's okay now. So not
Sir,
all
can
the
you-
times that you give the set.
I have an issue with that area.
Which area?
When we say X plus Y is odd, does it mean the paired couple, the plus of the paired couple being odd? And does that mean that should not be part of the set?
Come again. Come again.
All right, so we are saying X is related to Y and is given as X plus Y is odd.
Yeah.
So the X plus Y is odd. Does it mean the ordered couple, the addition of the ordered couple being odd, number one? And if it's being odd, does it mean the odd ones are not part of the relations?
We want all the odd couples. They form the part of the relation.
Oh, okay.
They are the part. But those who are not odd are out.
Oh, okay.
So it means if you want to write
Okay.
the relation R now should be the set of 1, 2, and 2, 1. Because they will give us only what that when we sum them up.
Okay.
Sir. Hello, sir.
Yes.
So it's based on the description given.
Yes.
X RY maps to X plus Y is odd, right?
Yes.
Okay.
So this way you are not be giving the relation. As somebody asked the question, like, is it always that you'll be giving the ordered couple? Okay. This way you are giving the main Cartesian or product, the cross of what S. But you are now asked to find the relation when you are being given the rule to follow. Are you getting it? So I even said something that the other pairs 1, 1 does not belong to R. That it's not a relation. 2, 2 is also not a relation. Since their summation do not give odd numbers. So we want the set of all those that when we sum them up, we get the odd number. That's the ordered couple that you want to form the relation. Any other question? So now let A be any set. Let A be any set. One of the important relations on A is that of equality. If A is any set at all. Now, one important relation is the equality. That is the set of the couple or the couple A such that A belongs to A, which is usually denoted by equal sign. So when we have A, it means your X is A, your Y is also A. You are not relating A to A. So what happens that we can denote it by the equal sign like this. Then when it happens that way, we call that relation as what? Identity relation or diagonal relation on A. So this relation is called the identity or the diagonal relation on A, and it will also be denoted by, so can you use this symbol, denote the identity relation. So we have this symbol A, or simply you can just use that symbol to represent the identity relation. All what we are saying here is that when you are having the cross of a set by itself, and the identity relation is the ordered couple whose both first and second component are the same, that AA. So in case we go back to just this example, we have the set of X like being 1, 2 here. So when we cross X by itself, we are the product as consider product as 1, 1, 1, 2, 2, 1, 2, 2. So if you want to get the identity relation here, they want to get A. So you go to each other pair whereby both the first and the second are equal. So you can say that the A now is 1, 1 and 2, 2. So these are set that we want to get, and you call it an identity relation. Is it okay?
Yes, sir.
Good. So to me, let's do this example. We have an example, the set of A, 1, 2, 3. Then we can get identity of relation A as AA, said that A belongs to A. So to me, we are not going here, we are pairing a number by itself. That will give that 1, 1, 2, 2, 3, 3. And this set now relation has become identity relation. And don't forget, the other subset of the Cartesian product, A cross A. Okay, if no question, now let A be any set. Then A cross A and null sets are subset of A cross A. Why? Because under set, we said that every set is subset of itself, and empty set is also subset of every set. So if we have A cross A, it's a subset of A cross A. And the null set is also subset of A cross A. And hence, the other relation on A called the universal relation and empty relation, respectively. Now let's try the following. Practice 1. For each of the following binary population R on N, you know this symbol is called the non-negative whole number or integer. So decide which other pair belong to R. Decide which other pair belong to the relation R. I, we have XR1 implies X. XRY implies X equal to Y plus 1. Y plus 1. II, SRY implies X divides Y. Divides Y. Now SRY implies X is odd. X is odd. I mean SRY implies X is greater than Y squared. And the last one being SRX, it implies identity what? Relation X. So let's see if we can just get them right. So let me give you just 5 minutes to do, or no, this was just 3 minutes. Finish it for me. Are you okay? So are you okay? Let's see. I. So what is I? So what is X, R, Y for I?
3 and 2.
3, 2. Y 2. Y 2.
The relation is asking if X is equal.
So X equals 3 here. So it's equal to Y equal to, are you okay? So if we add 1 to the Y plus 1, it will be the same as the 3. It means we have Y, S equal to Y plus 1. That's correct. So we have I now is 3, 2. Is that you okay? Or any question there? We want an ordered couple whereby the last term or the last component, if you add 1 to it, will be the same as the first component. That's the meaning of this relation, X equals Y plus 1. So among all the other couples here, it's only 3, 2. When you add 1 to the 2, should give the same as the 3. What about I? We say X divides Y. X divides Y. What
Yeah.
variation?
That's a pair of 2 and 4 and 2 and 6.
2, 4, 2, 6. Good. 2, 4, 2, 6. You are doing well. 2, 4, 2, 6. If you want a pair whereby X can go into Y. So Y is 4. So 4 divided by X will be 2 now become 2. And here Y is 6. Now X is 2. So 6 over 2 is also 3. You are doing well. What about I? X related by Y is given by X. It's odd. X is odd. Oh, with that thing, I just one multiple. Now this is nothing. Sha, ibu. Ana lihat Sha, mabe gani? Betul gitu ya. Nanti ada muka tu begitu. Open get them again. Well, we are no position in my top. So good. 2 years. I feel it. We have got a thing, something. Back on in but they are doing it. Oh. Oh. Good thing. Lovely. Love to visit with Juniper. With Juniper in my laptop. Yeah, Juniper. Oh, laptop. You are going to make money. I know that when you make money.
I think say is in a
Yes, so
okay. Am I free now?
So what about Ivy? Ivy. X is greater than y squared. X is greater than y squared.
So that is 2152.
2, 2, 1 here.
And 52.
Okay, okay. The last one.
The last
X greater
one
than
is 2, 2, and 3,
2,
3.
2, and 3, 3. Good. You are good. You are done with this evening. That's good.
So all of us did it together. So we all went through it.
What? You know what? Is that what?
So when you went offline, all of us did it together. So we
Okay,
all
okay,
went through
okay,
all of
okay,
them.
That's good. That's good. So now let me go types of relation. Types of relation. Now that you know the relation, you should know the type that we have. We have one-to-one relation. Now you are talking about one-to-one relation. It's a type of relation whereby the elements from the domain map to one and only one distinct element from the codomain. So like one-to-one. Again, nobody is sharing its partner with anybody. So every element, some element in the domain is having their special partners from the codomain. So example, we are having a set X equal to 1, 2, 3, 5, 4, 5, and we have Y equal to 1, A, B, C, D. Now if we look at X related to Y, then we have 1 map to C, 3 map to D, 4 map to B, and 5 map to A. So you could see that some elements from the X are mapping to the special element of Y. It means they alone mapping to just like A, 1. 1 is having only C. Nobody is sharing C with 1. And one is not having any other partner apart from C. The same way 3 is having D, 4 is having B, and then 5 is also having 8. So each one of them is having its special partners. So what happened that we say it was 1-to-1 relation. Is that okay? Are you okay?
Yes,
Yes,
it's clear,
sir.
sir.
Okay. So see that from the diagram, X related to Y is given by what? The set of ordered couple 1C, 3D, 4B, 5A. So you could see that 1 appears 1, 3 appears 1, 4 appears 1, 5 appears 1. The same thing to A, D, B, A. So when it happens that way, then you cannot see, even without a diagram, you can see that this is 1-to-1 relation. So both first and second components in each pair appears once in R, hence it is 1-to-1. Now, typical example is maybe when you go to the Christian marriage, we are saying that every man should have just one woman. Are you okay? So you can say the 1-to-1 relation. So if you're a Christian and you go in for 2 wives, then you are out of the relation. You are not part of the relation. I get my point.
Yes,
Is that
sir.
example okay?
Yes, sir.
Good. So let's also move on to another aspect. That's one-to-many. One-to-many. As the name implies, it means some elements from the set X will be mapping to more than one element from Y. So it means some elements from X will have more than one partner from Y. It means domain, element of the domain will have more than one. Some of them will have more than one partners. So for example, the diagram that we have here, we are having one map to A and the same one is also mapped to C. So one-to-many. One element from the domain is now having many elements from the codomain. That's where you got the name from, one-to-many relation. So we have 2 maps to B and 3 maps to D. But one is having 2 partners. Hence, it is called one-to-many. One in the relation of the domain and the many in the relation of the codomain. There's one-to-many. So if we look at this, we can see the relation as 1A. So we have one, the first part, first component here. So we have A. We have the same as 1C. So we see that one appears twice. Therefore, it becomes one-to-many.
Hello, sir.
Yes. Yes, I'm listening.
That is bad. Let me just point you.
I think we have to stop it and come and continue. Are you okay?
That's okay, sir.
Yeah, so let's reschedule it to another day.
Okay, sir. Thank
you
you
very
very
much.
much.
Should I end it or should I leave you on?
Sir,
Yes,
please,
sir.
you can end it, sir.
End it, sir.
So, colleagues, let's go back to the next lecture. Thank you. Bye.
Or should I leave you on, eh?
No, sir, you can please end it.
Okay.
Yes, please. Thank you.